All right, next example. Find the zeros and graph. Does everybody have their graphing calculator with them? If so, you need to get it out. Find the zeros and graph. You have a function in standard form, or factored form, sorry. You have, your factors are x minus 2, x plus 1, and x plus 3. Just by looking at that, you should be able to figure out your zeros from factored form. My zeros are from here, positive 2, because that would make this factor equal 0. So you put a point at positive 2. Negative 1 is another 0, and negative 3 is the third 0. So you should be able to list the zeros just by looking at it in factored form. Now the graph part, I don't care how exact this is, but you're going to go to the calculator and get the basic curve, or what the curve should look like. The most important points are the 3 zeros here. All right, so get out your calculator. Go to y equals and type in the function that we were just looking at. Why is that not coming out? Is that the same one?
Yeah.
X minus 2, x plus 1, and what's the other one?
X plus 3.
I don't know why it's not showing up.
We have to put it in parentheses.
Yes. Huh. It's weird.
What is DIMs?
Sweet.
What's wrong?
It says,
Invalid dimensions?
yeah.
You probably typed it. Are any of your plots highlighted at the top?
What's the third one? X.
Is anything highlighted at the top?
I think I hit a button.
Okay.
Plot 1 is,
Plot 1 cannot be lit up, so go all the way up to the top and hit enter. None of them can be lit up. All right, that should be x minus 2, x plus 1, and what was the last
I
one?
got you.
X plus 3.
X plus 3. Hit graph. You should come up with this graph, and then just take that and copy it onto your paper. And that's what I did.
I never get
I'm not too concerned about exact points other than those 3 zeros. Yes?
Never mind, sorry.
Lanzer, what's wrong?
I didn't get that.
You typed it in just like I did. Parentheses, x minus 2, x plus 1, x plus 3.
Yeah.
Hit zoom 6. See what you get.
Where's that?
Where's that?
Zoom, and then 6.
I got a different table than you.
Where's it?
I'm not worried about the table. All you should
Do I
get,
do that for every time?
No.
I do?
Oh, there we go.
because zoom 6 takes you back to the standard graph of negative 10 to 10 and negative 10 to 10. So right now it's set on that, so unless you do something to change that, it will always go to that graph.
So when we
Yeah.
graph this, we just have to make it look sort of like this.
Correct.
So we can, all we have to do is write XY axis. And just put it in
Mhm.
that.
Yep.
But
So
we'll
that's
have
what
to-
I did.
We'll have to say what the zeros are
Correct.
before.
So that's what I did right here.
Why is
I
How do we
just
figure out
traced
the zeros?
what I saw on the calculator. Huh?
I missed how you figure out what
It's not the
the
zero.
Zeros come from the factors. Positive 2 would give me 0 here, so that's a 0. Negative 1,
Yeah,
negative
if you
3.
hit second.
So your zeros go on the x-axis. Okay? Yes, ma'am.
Zoom 6.
How come you didn't combine, how come you didn't fold and do the stuff that you did last time, or you just didn't have?
You could, but it won't help you in this problem because it's asking for the zeros. It's easy to find the zeros in factored form, not standard form. So if you multiply it all out, you're not helping yourself out any. And the graph, you can either graph it in factored form or standard form. It's up to you.
My last curve isn't going back up.
Say that one more time.
My last curve isn't going back up.
Okay, let me see. Well, oh, that's because you have x negative 2. You have to have x minus 2. Change that negative to a minus. Okay? And then you should get it. All right. So everybody should be able to look at it in factored form and figure out the zeros. All right? Next example. Write a polynomial. So this is same thing we just did.
Do we need our
except-
calculator?
No. except in this one you are given the zeros, so you have to write out all the factors, but it says to write it in standard form, not factored form. If you're given 3 zeros, -2, 3, and 3, your factors have to be x plus 2, x minus 3, and x minus 3. And then that goes back to what we did in one of the previous examples, multiplying it from factored form to get it to standard form. So I multiplied the first two factors, x plus 2 and x minus 3, to end up with x squared minus x minus 6. I took that result and multiplied it to the last factor of x minus 3, and what do we end up with? There's your answer in standard form. So we were given 3 zeros, had to write it in factored form first, and then change it, multiply it out to get it to standard form. So how would you classify this?
Same way we did the other.
Yes, same way we did the other one, which is a cubic polynomial of 4 terms. Question on that one? All right, now with this one, this leads us into the last example, which is multiplicity. If you have more than one zero of the same number, that leads into multiplicity. So right here, the next example asks you to state the multiplicity. I would have a multiplicity of 2 at 3, because I have 2 zeros at 3. Make sense?
Would you
Now
like
let's
to
look at the
define
next-
multiplicity?
I have a question.
Yes, you could. Yes,
That's the answer at the bottom.
that's the answer
It's in.
in standard form.
Oh,
Would you define it?
What?
Can you define multiplicity, please?
Yeah, multiplicity is when you have more than one zero at the same number. So here I have 2 zeros at 3. So I have a multiplicity of 2 at 3. I don't have a multiplicity of anything in -2. Okay, so the next one, state the multiplicity. First thing we have to do is get this in factored form. So your GCF, x squared, and then factor this. So my zeros from here are -2,
Negative 4.
-4, 0, and 0. Right? Because you have x squared. If it was just x, it would be 0. But we have 0 and 0, so I have a multiplicity of 2 at 0. Would be how you state the multiplicity.
I don't understand.
Okay? Do you understand how I went from standard to factored form?
Yes.
Okay. So whenever you get, at this point, it might help if I list the zeros here. My zeros would be x could be 0, x could be 0, x could be -4, and x could be -2. Now,
Where did you get that from?
hold on one
Like,
second.
where are the first 2 zeros?
Now, just looking at the original problem, the standard form problem, what's your degree here?
Quartic.
Yeah, so 4th degree polynomial quartic. So the degree also tells you the number of zeros there are. So if we have x to the 4th, we know there are 4 zeros. Here are my 4 zeros. 0, 0. Don't just put 1 0. Right there, you should know you're missing 1, because we know there should be 4. So it's 0, 0, -4, and -2.
Oh, that's.
So now that I have more than 1 at 0, I have a multiplicity of 2 at 0.